This is problem number 5 for assessment number 10. And this problem says use Gauss-Jordan elimination to solve the system of equations. So if we're going to use Gauss-Jordan, let's go ahead and start by writing this system of equations in 3 variables, and putting it into a matrix. So we have 2, -1, 3, -2, 1, 2, -2, 12, 0, 10, 3, 1. Now remember, we're trying to go for the identity matrix here. We want to get this matrix in here to say 1, 1, 1 down the diagonal, 0's here, and 0's up here. That's our goal. So they already give us a 0 right here. That kind of makes it a little easier on us. So let's go ahead and start by trying to make this a 0. So I'm going to take -2 times R2. And when I multiply -2 to the middle, I get -2, -4, 4, -24. And this will be 2, -1, 3, -2 on the top, 0, 10, 3, 1. We're going to add row 1 with row 2, and that's going to equal row 2. So when we add these, we're going to get 0, -5, 7, -26. And on top we still have 2, -1, 3, -2. On the bottom we still have 0, 10, 3, 1. Now I need to cancel this one on the bottom to be 0, so I'm going to multiply the middle row by 2. So we're going to say 2R2 and when we multiply 2 times R2, we're going to get 0, -10, 14, and then we're going to multiply -26 by 2, that's -52. And this will be 0, 10, 3, 1 on the bottom, and we get 2, -1, 3, -2 on top. Now we're going to take R2 plus R3, and that equals R3. And when we add those, we get 0, 0, 17, -51. This is still 0, -10, 14, -52, and this will be 2, -1, 3, -2. Now I'm going to multiply the middle row. I'm going to multiply the middle row by a half just to essentially make it smaller, all even. So I'm going to multiply 1/2 times row 2, and I'm going to multiply 1/17 times row 3 to make that smaller. When we multiply the bottom row, that'll give us 0, 0, 1. How many times does 17 go into -51? It does go in there 3 times, so it's -3 here. This is 0, -5, multiplying that by half, so that's 7, and -26. And we want this to be 2, -1, 3, -2. Now I'm going to multiply the top. I need to get this to be 0, so I'm going to multiply the top by -5. So I'm going to multiply -5 row 1. We multiply -5 times row 1. We're going to end up with -5 times row 1 will be -10, 5, -15, and 10. This will be 0, -5, 7, -26, and still 0, 0, 1, negative 3 on the bottom. Now we're going to take row 2 and add it with row 1, and that'll be row 1. When we add those, we get negative 10, 0, negative 8, and negative 16. The middle row is still the same, 0, negative 5, 7, negative 26, and then we have 0, 0, 1, negative 3 here. Now we just got to cancel this to be 0 and this to be 0. So let's start by doing 8 times row 3. And when we do 8 times row 3, 0, 0, 8, negative 24, 0, negative 5, 7, negative 26, and negative 10, 0, negative 8, negative 16. Row 3 is going to be added with row 1 to equal row 1. And when we do that, we get negative 10, 0, 0. When you add those, you end up with negative 40 there. And we still have 0, negative 5, 7, negative 26, and 0, 0, 8, negative 24. I'm going to go 1, and actually negative 1/10, row 1 to simplify that, and I'm going to go 1/8, row 3 to simplify that. And when we do that, we're going to get 1, 0, 0, 4. On the bottom we get 0, 0, 1, negative 3, and we still have 0, negative 5, 7, negative 26 here. Let's multiply the bottom row then by negative 7. So negative 7 R3. And when we do negative 7 R3, we get 0, 0, negative 7, 21. We still have 0, negative 5, 7, negative 26, and 1, 0, 0, 4 for the top. We're going to take R3 plus R2, and that equals R2. And we get 0, negative 5, 0, negative 5. We have 0, 0, negative 7, not negative 21, 21 on the bottom. And we have 1, 0, 0, 4 on the top row. Last step, we're going to take negative 1/5, R2, and negative 1/7, R3. 1, 0, 0, 4 on top. 0, 1, 0, 1, 0, 0, 1, negative 3. So our solution is 4, 1, negative 3 using Gauss-Jordan elimination.